Hello and welcome to the Facts on Open Automation show of ASMPT, the #1 solution provider for electronics manufacturing. We live in the age of automation. Do you know how much possibilities to have with automation in your production? Do you even need full automation in your production? We don't think so. You should consider open automation. How much automation makes sense and how to navigate through this jungle of automation, that's what we are going to explore together in this show. But let's first see an example for solution we are going to see throughout this show. Let's head over to our Center of Competence in Munich to Rob Raine.
Thank you, Laszlo, and welcome to our Center of Competence in Munich, where we can demonstrate any of our ASM equipment, either locally or remotely. What I'd like to show you now is a great example of open automation. We asked our partners at CTS and NewTek to give us a solution that delivers PCB magazines to the line. Now, CTS is an example of a solution provider. So they source their robots from Omron, they add the roller conveyor to the top and provide the transfer station that we can see here. And it's CTS fleet management software that is coordinating the activity you can see right now. So there's a communication between the robot and the transfer station that ensures that this PCB magazine can quickly and easily move across into the robot. This is internal in CTS's system. The robot has an order to take this magazine and deliver it to the production line, where a NewTek loader will then take over and make it ready for production. Now, even an autonomous robot can use a little help from time to time to get the best positional accuracy. This robot uses durable magnetic tape on the floor to align itself with the loader. The second stripe is so it knows where to stop in front of the loader. At this point, CTS fleet management software is communicating directly with the loader to manage the handshake for the transfer of the magazine into the loader. From this point on, the NewTek loader takes over. It will position the magazine ready to load boards into the printer. But before it does that, the loader will send a Hermes board available message to the printer, and the printer can use that to trigger an automatic program changeover.
That was a smooth example for open automation. But what is automation anyway? Is it hard to do? What happens if I don't want to do it? And to what extent shall I do it? Well, that's what I'm going to discuss with two nice colleagues of me. So first of all, Rob Raine himself. Hello, Rob.
Hi, Laszlo.
And Alexander Hagenfeldt. Hello, Alex.
Hi, Laszlo.
Nice to have you both here.
Thank you.
First of all, can you both describe your journey to automation so far?
Okay, well, for me, it goes back what feels like an awful long time now to school projects, but the first real industrial experience was joining an SMT factory in 1990 and seeing automated placement machines putting down surface mount components. In 1997, I joined DEC, and so it was very interesting to start looking inside an equipment provider. And how DEC evolved from using automation for the mechanical processes of solder paste printing and moving on into integration with software systems, adding new features, process interlocking, working with MES, and then in more recent years being involved in ASM's integrated automation projects where we've done research into this. And then of course in 2021 I've joined the Munich team and heading up the Open Automation Solutions marketing, and that's why I'm here today.
Cool, Rob. And you, Alex?
Yeah, for me, it also started, I had my first experience about manufacturing processes in general in university, and then I saw my first ABB robots on a field trip, got really excited about that, ended up working for ASM, and then I've been in this incredible, fortunate position to be an observer of the automation that is happening in our industry, because we are a global company, and I've got to visit a lot of these different factories and experience hands-on what our customers are working on, and I think that has given me a lot of perspective. When you are exposed to different sources, then you start seeing patterns as well, right? And it's been a very interesting journey for me.
Your patterns are what we are interested in. So what is automation at electronic manufacturing?
Well, first of all, everyone's working on it, right? I think it's a problem everyone is somehow confronted with. I think the SMT industry is quite standardized. If you look at the process that we are doing, right, in an SMT line, there's already an incredible amount of automation, yeah? And the problem that we're trying to solve right now is more what's happening around the line. And I think what's important to note here at the beginning of our conversation is that automation is not synonymous with robots, yeah? So having robots perform repetitive tasks, yes, that is a part of it, and that is something that is easy to relate to because you can see it, and it's impressive, right? But it's also, automation is also about the connections of the different systems and the data communication that is happening in the background, yeah? So let's keep that in mind.
So Rob, the solution you have shown us, it's showing an AIV. So is automation, and AIVs are very popular now, very trendy thing. Is automation a trendy thing just for now, and is it difficult to do?
It's not just a trendy thing for the moment. We've been automating for a long time. As Alex intimated, this has been going on for many decades now, since someone realized that a person sitting at a desk with a soldering iron and a roll of solder is not going to be something that scales. And of course, that's the whole reason SMT business has come about. So the trend going forwards is going to be to keep on with that steady automation. And we are a very steady business that delivers returns on the investments that we make. So in terms of difficulty, that ROI is very important. So some processes can be automated easily, others can be very big and very expensive. So what we want to do is help our customers recognize the difference between the two, to understand that return on investment and where to actually begin. Maybe not go for the big high value return on investment, but to start with something smaller and get the process rolling.
Perfect. Why do we need automation?
Well, there's a lot of drivers towards that, and one of the controversial ones, of course, is about labor, where there's a lot of perception that people are going to lose their jobs because of automation. But the reality is that it's getting difficult to actually fill the roles. Electronics is expanding. People want more and more electronics. There's not so many people to go in. And of course, the pandemic has had an effect because people are more and more thinking about working from home these days. So a factory is the absolute opposite of working from home. So this is part of the trend that means that we need automation.
Yeah, I picked up on an interesting fact the other day, which is that apparently e-commerce has increased by 30% essentially since the pandemic started, right? And that's quite a massive figure. So think about the logistics behind getting all of these goods to the individual consumer. It used to be we manufacture things in bulk and we bring it to one location and then somebody comes by, picks it up and takes it home. Now we have to send it to thousands, well, millions actually of people to their homes, and then chances are they're going to send it back anyway, right? So that creates or has created a whole new problem that we have to solve with a complexity that is not solvable without a high degree of automation. And that type of problem is coming up in the electronics manufacturing industry as well. So we're seeing, increased variations of the products that we need to manufacture because people want customization. We're seeing these batch sizes go down, right? So we need to cater to that flexibility, and we need to be able to produce in a way that we can bring this product to the end user as effectively as possible.
Absolutely. So Alex, then what happens if someone doesn't want to automate?
Okay, so I think the thing to be aware of here, yeah, there's actually a danger that exists for our customers that if they don't automate chances are that somebody else will. And if they do, that means that they will lose a competitive advantage that they might have right now, right? And I think that's the real that's the thing here. That's the psychological game that is happening. And so by not automating, you are basically running the risk of losing out long term.
Absolutely. And as Rob mentioned, the ROIs can be staggering. Rob, what are the goals of automation?
Well, the clear ones are we want to increase quality. Automation does this by making the process more repeatable. When you take people out of an equation and put robots back, then you make the process more stable and more repeatable. Robots don't suffer from the human effects of fatigue or boredom, not enough experience, sometimes too much experience. So another one is getting the quantity up. So when the processes are more repeatable, you can identify with data analytics, which is another form of automation, the collection and analysis of data. Use those to modify the process very directly by changing parameters in the machinery. And of course, the last one is about reducing the cost. So robots, when implemented correctly, can very often be cheaper to operate than human labor.
Brilliant. As mentioned by Rob in his video, we are going now back to the Center of Competence and look at our second solution for open automation. When we come back to the studio, we will discuss the topic of how much automation makes sense.
And where better does automation make sense than in the delivery of materials? Pretty much where it all started. So this story begins with the generation of a pick list. That could be a pick list from a new setup in the preparation area, or a pick list of the next 30 minutes of reel changes that are going to be required at the production line. So what we're seeing here is a collaboration between three major systems. One is the KNAPP Fleet Manager and this KNAPP robot. Another is the ASM Material Tower. And the glue that connects these together is Critical Manufacturing's Factory Automation Module. So the first task that the KNAPP was given was to collect an empty cassette and to bring it to the tower. The KNAPP operates by comparing sensor input to a piece of angled metal to align itself cleanly with the front of the material tower. Once that's in place, it can start the transfer. And when complete, the material tower can continue with the job of preparing for the pick list. The robot, on the other hand, can now continue and complete any other tasks that are required. So as a member of a fleet of robots, this KNAPP could go on to do any number of other tasks. The pick list from the material tower could be quite large. The material tower itself can hold up to 960 7-inch reels. But when it is finished, a new task will be given to the KNAPP to come and collect the finished cassette. As the KNAPP approaches the material tower, there's an exchange of messages between the two systems and Critical's Factory Automation Module, which tell the KNAPP it's the right time to approach the tower once the cover has been opened. With the same alignment system, the KNAPP robot prepares to remove the cassette from the tower. Once the cassette has been successfully transferred back onto the KNAPP and the cover closed, the robot can now proceed out to the production line, which could be many hundreds of meters away. So once the robot has arrived at the line, all the operator needs to do is to slide out the trays that have the relevant reels on them, and then the complete replenishment of the feeders on the placement machine. Once all the reels have been exchanged, the operator can simply press a button on the robot and it will return the empty cassette to the preparation area.
Welcome back to the studio. Thanks, Rob, for this solution. One important question. All those solutions we have seen here, are they really available and customers can order them?
Yes, that's exactly right, Laszlo. What I would point out is that what we've seen so far, each of them is effectively a project. So what we can do is help customers work with those other suppliers to come up with a whole project solution. But everything you've seen there can be purchased, yes.
So let's go back to a very interesting question. How much should I automate in my production? And I've read this very interesting story about Elon Musk and the Tesla 3 production. So he tried to hyper-automate the production, and the robots were killing the Tesla production. It was a complete failure. So later on he tweeted that yes, excessive automation at Tesla was a mistake. To be precise, his mistake, and humans are underrated. So how much should I automate in my production?
It's a good question. I think you should automate as much as makes sense, and you really have to decide on a case-by-case basis. And I think Elon and Tesla, they had to learn the hard way. But I think they learned a lot in the attempt of automation that they were doing, right? But the reality is, when you're automating something, there is a point where increasing the level of automation becomes so difficult that it doesn't matter how much money and resource you throw at it, you're never really going to reach that 100%. Yeah, so you really have to keep a cool mind and think, okay, does this make sense now for what I'm trying to do? Yeah, and it's a challenge, but the important thing is you should continuously be asking yourselves, can I automate this? Yeah, what would it take to automate it? And continuously be making decisions whether or not it makes sense. And you have to keep looking what kind of technologies are emerging, because the markets are changing all the time and there are new possibilities every day. So you always have to keep asking and second guessing yourself. So maybe something is not automated today, but you could be automating it in a month from now, right?
So the cost of the solutions may drop in future.
Yeah.
So Rob, is full automation even possible in electronics manufacturing?
It is if you scope what you mean by electronics manufacturing. If you're going to mean the whole process from the beginning to the end, then at the moment it's not. Material packaging is a simple example that has been designed for people and machines to work with together. It's really not very good for working 100% automated. So realistically, to repeat what Alex said, it's pick the processes that you can automate that will give you that good return and that are relatively simple to do, and then take it from there.
Perfect. The solutions you have shown so far, they are somehow related to logistics. Are there other examples of automation we have in our portfolio?
Yes, and in a future show you're going to be seeing examples such as our APC, our all-purpose clamping on the printer. That means that the printer itself will be able to have 3 different modes of locking the board in place for printing, depending on what type of product it is, instead of mechanical adjustment of the printer. We're also going to show you smart pin placement, which of course we've had on placement machines and is now available in our TQ printers. And another example is our automatic waste disposal system. And rather than spend any more words explaining that to you here, let's go back to the CoC and take a look at the real thing.
And here we have our automatic waste disposal system. This is the most visible part. We have the waste collection system and the drive motor, but the real magic is happening underneath the placement machines, where we have a series of channels with a conveyor belt in with brushes that collect tape waste that falls through chutes that you can see here, the tape waste being cut from the feeders on the changeover tables. But the real advantage of the waste disposal system is how it collates all the waste into one place. One of the key factors to consider is that the waste on the machines is typically generated mostly by the kind of head that is using the largest components with the largest tape. Now that's typically a CPP head in the high position. So we did some calculations based on a lot of collected data, and we found that when one machine with the CPP head fills up that table, the twin head on the other side is at around 40%, but all those CP20P2 heads are all at only 7%. Now, if we add all these percentages together, it comes to a little under 200. And if we think that each table is 100%, and we have 8 tables, 800, 200 out of 800 is about 1/4. So we're only using a quarter of the capacity of the line for waste. The waste disposal system takes all of that waste and puts it in one place. And this bin is 3 times the size of all those tables combined. So this means that operators are visiting the line 1/3 of the frequency as they would if they had to come and empty the tables individually. And that's not the only thing, because when the operator comes to the line and they have to empty every table for a 4-machine line like this, they're going to have to do this 8 times. And they'll be bending down, taking the table out, standing up, putting it in a bin, then sliding it back in again. So it's a very manual operation, it's repetitive, and it takes time. By comparison, simply taking the bin and either exchanging it for an empty one or taking a bag out and putting a new bag in is much quicker. And while the table waste bin is out, waste from the feeders is falling on the floor. So there needs to be a regular maintenance program to clean that stuff up. So in summary, when we're talking about return on investment on something like this, if we use operator wages, and you can use your operator costs, we can say that an operator will visit the line 1/3 as often, and when they get there, they're going to spend maybe a quarter of the time or less. So we believe that will give a very favorable return on investment for this kind of automation.
Very cool piece of technology and an amazing ROI. Cool, Rob. So Rob, what is open automation?
Well, the key word, of course, is the open part. So we've talked a lot about the fact that automation has a very broad scope. It's not just robots, it's software. Open part is about making it easy to connect these things together using open industry standard interfaces. Things like IPC Hermes, things like IPC CFX, SexGem, there's a whole host of these interfaces. The key point about open is to make it easy to connect any one thing with any other thing and build up this network of automation.
Brilliant. And Alex, what is this 80-20 rule we are mentioning?
So the 80-20 rule is actually more of a rule of thumb, yeah? So Pareto's Principle, I think many of you might know it from other aspects of life, yeah? It's sort of this general thing that 20% of resources yield 80% of the results. So an easy example to understand is 20% of people on Earth have 80% of the wealth, right? So it sounds true, right? And by using a similar or the same principle, I think you can help identify what are good use cases to automate in your factory. And what we just saw is actually a great example of the Pareto Principle at work in an SMT factory. Because by installing an automatic waste disposal system, for the pick and place machines, you have removed 80% of the work that operators need to do to get rid of that waste, and you collect it in one bin, so it's 80% less manual labor for the operators. If you want to go 100%, so those extra 20, to have an AIV come pick that up and then dispose of it somewhere, and the whole logistics that is associated with that again, that's a much more difficult problem to solve. So by using the 80-20 principle, we quickly identified a automation use case that seems to be worth your while.
Perfect. We are, of course, here staying in Munich, but we are also interested in the opinion of other regions. For that, I have invited our Global Marketing Manager from Singapore, Kenneth Koh. Hello, Kenneth.
Hi, Laszlo, Alex, Rob, and a big hello to all our viewers online.
Kenneth, great to have you here. Can you please introduce yourself to our viewers?
Right. Thanks, Laszlo. Yeah, it's great to be here. Thanks for having me here today. My name is Kenneth Koh, and my team and I are responsible for helping electronics manufacturers in Asia, outside of Greater China, firstly, to be aware of, and secondly, understand the intelligent solutions that ASMPT SMT solutions can offer in order to help them achieve a high-performing integrated smart SMT factory. Thanks, Laszlo.
Brilliant. Kenneth, what is the difference between Europe and Asia in terms of automation?
Very interesting question, Laszlo. Let me give you some facts and figures. According to the International Federation of Robotics, as of 2021, there are more than 3 million industrial robots operating in factories around the world, out of which 32% are in automotive and 25% are in electrical and electronics manufacturing industries. And that's where we are, of course, most interested. 76% of the installations itself in 2021 can be attributed to 5 countries, namely China, Japan, USA, Korea, and Germany. As you can see, amongst these 5 countries, 3 are in Asia and only 1 in Europe. Further quoting from the same source, in 2020, the top 5 countries with the highest robot density, which is the number of robots installed per 10,000 employees in the manufacturing industry, are Korea, Singapore, where I am based, Japan, Germany, and Sweden. And again, we see out of these countries, 3 are in Asia and 2 are in Europe. Furthermore, it was recently reported that China aims to be a global leader in robotics with a new 5-year plan. So yes, automation adoption rate is really high in Asia compared to Europe. However, I would like to add that presently, adoption of automation is not so uniform across Asian countries. Thanks, Laszlo.
Amazing figures. So what is your opinion, or what is the opinion of Asia for open automation?
Yes, as mentioned earlier, automation is not so uniform across Asian countries. In Southeast Asia especially, many companies acknowledge the potential, but many are struggling to implement it. And one of the reasons is because of labor costs. Labor costs are so low or low enough in some Asian countries that the upfront cost of automation is difficult to justify. And also, a McKinsey report highlighted other impediments, such as defining business plans that will ensure ROI, or siloed data that has so far restricted integration of production information, or finding the digital and automation talents to implement it, the automation, or fears of cybersecurity risks, and even sometimes just a lack of coordination between business units and departments. So perhaps we have the experts here right now. Maybe Rob, you can help us. You can help some of our Asian viewers get some answers into how they can overcome these challenges. First of all, let's take a look at the labor cost issue, right? In some Asian countries, we say that labor costs are low enough that the upfront cost of automation is difficult to be justified. And so some companies decided to delay implementing automation. So in your opinion, is it okay for these companies to just wait?
No, I don't think they can wait. There are opportunities that countries like that have over countries that already have high levels of labour cost. So you mentioned China, and we know that China likes the idea of a 5-year plan. If as a company you take that approach and say, right, I can start to automate now, I can make it a steady process, the costs of running the project will be lower if the labour cost in your area is lower. You can identify the people in your factory who you're going to move into new positions because you're automating some of the other things away. And all the time you've still got this lower labour cost available to fill gaps or to choose exactly where you want to automate.
Right. Thanks, Rob. We have another challenge here, right? About integration of departments and information. So is it true that automation projects need to be driven by a company's C-suite level management? Because as we mentioned, there are so many different teams managing different topics: production materials, daily production, equipment maintenance, IT. And they might have, siloed databases, and they often have their own KPIs to meet. And so they might find it challenging to coordinate and embark on automation itself. So how do they go about doing? Do they really need is this only a top-down level approach?
No, the automation itself, it can be very varied. So there is the impression when we talk about automation that people have the idea that there is a production line full of people who are putting lots of screws together, and instead of that, we're going to throw $3 million of robots at the problem and hope it gets solved. And when you're talking about capital investment of those sizes, then of course it's the C-level executives that are going to be making the decision. But automation can happen at so many different levels, from something as simple as saying, let's use something like Hermes or ELS to make changeover in a line simpler, which is just software upgrades usually on equipment, and then people can step away from needing to manually set conveyors and loaders as they do today and just let the whole thing run evenly. The other thing to remember is to embark on automation projects from a fresh start. It's easy to say this project has got the biggest ROI, so let's do that one first. But if that's a big, expensive project, you could well run into problems. Maybe it's better to pick an easier to implement project with a smaller scope that does have a lower or longer ROI and use that as your model for then automating further in the future.
Right. Thanks, Rob. It's very interesting. You mentioned about Hermes and ELS. So when we talk about ASM's open automation, does it mean ASM solutions are able to easily integrate with existing factory setup, machines, IT systems, and all the different communication protocols that's needed? As you mentioned, ELS, IPC Hermes, SexGems, and actually how many and even who are the partners that we can work with to deliver automation?
Well, that's a very interesting point you make there, and we've mentioned ELS a couple of times, it's an interesting example because ELS is not really an open protocol. The suppliers of it need to license this, whereas Hermes, of course, is open. You can download the information from the website and implement it as you want. And if we talk about ASM factory automation and how that can integrate with equipment, well, from the box or out of the box, support for standard protocols like SexGem, OPC-UA, and many other standards are in there right from the beginning. And in fact, in the CoC in Munich, we did ourselves integrate a deck printer using SexGem, and it literally only took 20 minutes to hook up an event from the printer to actually triggering some automation activity in the system. And we've used that to work with suppliers like Knapp Robotics, CTS using Omron robots, the Lopad Corporation providing our table exchange systems, and Viscom integrating into the line for AOI, and many others. The whole point of open is that we're ready to work with anybody and help connect our customers together and connect our customers to other suppliers to be able to deliver an open solution.
Right. Thanks, Rob. I think it's very fantastic that you mentioned the openness that we have and the protocols that we're using, open, versus some of the closed ones or proprietary ones. Yeah, I think perhaps even right now, this information perhaps already gave some of our viewers some confidence in open automation already. Hopefully, as we proceed further, we will get they will find out more from us, and then and engage us to talk about. Implement some of these topics in their factory. Thanks, Rob.
Absolutely, Kenneth. And some of our customers can engage you in our Center of Competence in Singapore about this topic. So,
yes, of course.
Thanks for being with us. Thanks for being here. And thanks for joining our discussion. And goodbye to Singapore.
Thank you, Laszlo. Thanks, Rob. Thanks, Alex. And thank you to all the viewers. Have a good day.
So that was Kenneth Koh from our location in Singapore. I have finally 2 questions to you. So based on our past, some of our customers believe that we are still equipment supplier only. So how does this fit with the solutions we have seen throughout this show?
Well, I hope that we have been able to demonstrate that we are not just an equipment provider anymore. Yeah, and this is something that didn't change overnight. Of course, we started off building machines for the SMT industry, whether it was printers or pick-and-place machines. But over the years, and we've been in this industry for over 30 years, we have developed more and more solutions around these machines to help our customers integrate them to further increase the level of automation in factories. So this is a change that has been going on for many, many years, and we've been a part of this journey together with our customers. So being a solutions provider is something that we are very proud of as ASMPT.
So Rob, what is your final summary review on open automation?
Well, I think the main thing to point out is that automation is obviously here to stay. Industry 4.0 has been around some time, and there's a reason there's the number 4. This is an ongoing process and always has been. So the Industry 4.0 aspect means that we have more and more data, and we need to work with that data and deliver automated solutions that use that data correctly. History has shown us that automation works. It doesn't matter how far back you go in time, for many thousands of years we've been automating something. So what we would really like to end on is to ask you to bring us into your automation projects, to let us help you understand how we can make the most out of automation in your SMT factories. Come to our CoCs, have a look at what we do, start the discussions, remote demos. Please just let us help you.
Thank you, Rob. Thanks, Alex. It was cool to chat with you. So to conclude the show, I have also 3 recommendations for you. Please download the white paper. You see here the link. Also, as Rob mentioned, please contact our Center of Competence for more information and a tailored show for you. You can also contact your friendly ASMPT account manager for that. And finally, if you want to touch, visit and see us live, we have following upcoming events. On March 29, the InnoElectro in Budapest, April 13, NEPCON Korea in Seoul. The next episode of our show will be on April 27. It is going to be about where to start automation, and we will see Rob again. We will present you practical tips on how to decide which steps in your production should be automated. Rob is going to examine a complete SMT line regarding automation, and we will see the thought process of a production manager in regards to where to start automation. Until then, thanks to my colleagues for talking with me. Thanks to you all for being with us. Stay safe and have a nice day.